The final price index we can focus in on is known as the GDP deflator, which is an index of the average prices for all the goods and services in the economy, including all the components of GDP. We have consumption, investment, government spending, and net exports. Essentially, it is the broadest measure of inflation that we have. It includes everything that the United States or the country is going to be producing. It essentially combines the CPI and the PPI together. As before, we go ahead and have a formula in order to calculate out the GDP deflator. And it's just a little bit different compared to what we saw with the CPI and the PPI. So there's two formulas for the GDP deflator. I'm going to give you the easy one right here. So the GDP deflator is equal to nominal GDP divided by real GDP. So real GDP multiplied by 100. So what exactly is the difference between nominal GDP and real GDP? Well, nominal GDP is exactly what we calculated out in the previous chapter. It uses a current dollar value, or what you see. So here, anytime you see the word nominal, it just means it uses the current year's prices. So here, nominal is a current dollar value. Current dollar value. So what you see. So that $21 trillion worth of GDP for that particular year was seen as a nominal value. It's exactly using the same exact year's prices. Real GDP, on the other hand, is going to be a little bit of a better measure for GDP, as we noted, because it controls for prices. It's something known as a constant dollar value. So here we have the constant dollar value, meaning that we have some type of base year. It adjusts for inflation. So adjusts for prices. And it uses a base year. So uses a base year. So knowing this, nominal and real GDP, taking the sort of division between these two, multiplying it by 100, we'll get the GDP deflator. So real GDP, it uses a base year. I think the current calculations that the BLS uses either 2000 or 2010 as a base year. But once again, the choice of base year is pretty arbitrary. So let's go ahead and use the GDP deflator in order to calculate out the inflation rate. So suppose I give you an example as such. So example number 1, find the GDP deflator. Find GDP deflator if nominal GDP in 2018 is 7,692, and real GDP is 7,425, is 7,425. Suppose that I tell you that's also in the year 2018. Suppose that I tell you that it uses 2010 as a base year. So this calculation of real GDP in 2018, it uses 2010 as a base year, So that calculation uses 2010's prices. One additional piece of information I can provide to you as well, the last piece of information, is that nominal GDP in 2010 is 7,280. So find GDP deflator if nominal GDP in 2018 is 7,692 and real GDP is 7,425, which uses 2010 as a base year. The nominal GDP in 2010 is 7,280. So let's go ahead and find the GDP deflator in 2018. GDP deflator in 2018. And we can simply go ahead and insert the numbers that we know into the formula right here. What is the nominal GDP in 2018? Well, we're given that piece of information right here, 7692. So you know that goes in the numerator. What is the real GDP in 2018? That's going to be 7,425. So just going ahead, inserting these numbers into our formula, multiply by 100, and we will get 103.60. So the amount of the GDP deflator in 2018, that price level, is 103.6. Does this one singular number tell us anything? Is there anything we can interpret from that? And the answer is going to be no again. So remember that in order for us to compare the CPI, we need to have two different CPI values in order to say anything about inflation. The same idea is true here with the GDP deflator. We need two GDP deflator price levels in order to say anything about inflation. So what's another GDP deflator we can solve for? That's going to be the GDP deflator in 2010, the base year in this instance. So GDP deflator, and base year. So base year. In this instance, it's 2010. So do we have this information being provided to us? Do we have a nominal GDP in 2010? And the answer is yes. That information right here, 7,280. So we know that's going to go in the numerator. We know it's going to be multiplied by 100. But do we have a real GDP in 2010? And the answer is not directly, we don't. But however, remember the discussion that we had in terms of the CPI in the same base year. If we have a CPI in the base year and we want to calculate that out, what did that always have to equal? That always had to equal 100. And the same is going to be true here with the GDP deflator in the same exact year, the same base year. So we know the calculation is going to have to be exactly equal to 100. So what do you think the real GDP is going to be in the base year? It's going to be exactly equal to the nominal GDP. So 7,280 here as well. So nominal GDP and real GDP, there's the same exact value anytime we want to take a look at the base year because they're using the same exact prices. So once again, something a little bit to be cognizant about. So no matter what, anytime we want to calculate the CPI or the GDP deflator in the base period, in the base year, it's always going to equal to 100. So we'll always equal 100 in the base year, So keep that in the back of your mind. Now that we have two GDP deflator values, we can go ahead and say a few notes about inflation. So here we use that same inflation formula that we brought up under CPI. We insert the GDP deflator instead of the CPI. It's a GDP deflator in the current period divided by the GDP deflator in the original period times 100 minus 100. So keeping that same formula consistent, we have the inflation rate. It equals to the GDP deflator in the current time period, or the year that's closest to us, that's 2018, so 103.60. We divide it by the GDP deflator in the original time period, or the year that's furthest away from us, which is 100, and then we multiply by 100, close the brackets, subtract out 100, and the number that we get from that is 3.60%. So inflation increased by 3.60% from the year 2010 to the year 2018. So once again, we don't need to have two consecutive years against one another, and we don't necessarily just need to be comparing against the base year, and that's exactly where we can have a little bit more complex calculations with this. But the same steps are going to follow in calculating out the inflation rate itself. The second formula that we can use in order to figure out the GDP deflator is going to be a little bit more conventional if we want to go ahead and convert nominal values into real values. So take a look at this formula right here. So if anytime we want to adjust nominal values to real values, we're going to go ahead and use this formula right here, where the real value equals the nominal value times the base year index divided by the current year index. And it's exactly the same formula that we brought up right here, the more simple version of the GDP deflator, except we're algebraically manipulating it a little bit. So if we get the nominal GDP on the left-hand side right here and do a little bit of algebraic manipulation just to isolate it, it's exactly where we're going to go ahead and get this formula in this instance. And you can go ahead and use either one to solve the GDP deflator. You'll get the same exact answer. But this one's going to be a little bit more relevant for us if we have nominal values and want to convert it into real values. So excuse me, I think I said nominal values on the left-hand side to isolate. We want to isolate the real values on the left-hand side here in order to get that formulation. So let's go ahead and do another example of this to convert that nominal into a real value. So here, second example we can ask is, what is real GDP? What is real GDP? In 2016, if nominal GDP is 128.2 billion, so roughly about $18 trillion, and the GDP deflator is 112 0.3. So do we have enough information to convert this nominal value into a real value? So use that formula that we just saw. The real equals a nominal times the base year index divided by the current GDP deflator index. So here, nominal times base year index divided by the current year index. Do we have a nominal value? Yes, absolutely we do. It's that 18,128.2. So here, that nominal GDP is 18,128.2 billion. Next, we need to go ahead and figure out the base year index and the current year index. Well, we have a current year index, which is 112.3. But do we have a base year index? Is that information provided to us in the information for the problem? And the answer is, once again, not directly, but indirectly. What did we say about the base year index? What did that always have to equal? It always had to equal to 100. So just go ahead, anytime you see that base year index, you just insert that 100 into there. And now we've successfully inserted all our unknowns in order to convert this nominal value into a real value. You plug all of this into your calculator, and the real GDP in 2016 for the United States, these are actually using the real numbers, is going to be roughly worth about $16 trillion. So $142.6 billion. So real GDP is equal to $16,142.6 billion, while nominal GDP, which is using 2016 year prices, is $18,128.2 billion. And remember that we said that real GDP is controlling for these prices and adjusts for inflation, so it's a better measure of our standard of living if we want to make comparisons against countries. So two different formulas for the GDP deflator, one easy, one fairly complex, but depending on the type of information that is given to you and the question that you want to ask, you know exactly which of these formulas to use. And just a little bit of a history about the GDP deflator, we can notice exactly how the GDP deflator is showing inflation, deflation, and disinflation over the course of US history. The last time that we had any big bout of deflation was during the Great Depression, where prices dropped nearly 10%. But with World War II, we saw very high rates of inflation. World War II actually helped get us out of the Great Depression. And then we see very high spikes in inflation and prices when we had OPEC. They increased the price of oil. But since then, we've noticed that there's a sort of deflationary pattern since the United States ever since then. And our inflation rate really hasn't fluctuated all too much. It's been staying within that 2 to 4% range that the Federal Reserve has targeted. So three measures in terms of inflation using three different price indices. We have the CPI, we have the PPI, and the GDP deflator. So with all of this in mind, let's go ahead and turn our attention to see exactly who's going to be benefiting and who's going to be harmed anytime some type of inflation is going to be happening. We'll take a look at that in the next lecture.